Hey everyone, my name is Jeffrey Falkinburg and I'm a professor here at UNL in the School of Computing. I'm excited to be able to sponsor a third year of the Husker Scope project. This project this year will be more hardware focused and will benefit students and faculty throughout UNL and around the world by providing a useful piece of test equipment. The Husker Scope app is an all-in-one cross-platform application that implements a dual-channel function generator, AM/FM modulator, oscilloscope, and spectrum analyzer functionality for use within UNL engineering courses and around the world. The Husker Scope app currently interfaces with other devices through a 3.5 millimeter audio cable and are limited to audio frequencies and low voltage applications, and we use them in some of our courses. This year, we'd like to redevelop the hardware interface for a more advanced dual-channel oscilloscope and spectrum analyzer functionality. We'd like to enable two-channel BNC inputs to the hardware using Bluetooth to transmit to the app. We'd also like to increase the serial transmission speed through the Bluetooth, as well as design and build that new hardware likely on an FPGA to increase the sampling rate for those two ADC inputs to 1 to 10 million samples per second, as well as enough on-chip RAM to store at least two buffers of 1 to 10 million bytes. We'd also like to implement a multi-channel logic analyzer functionality into the app capable of taking in up to 8 digital inputs, sampling at 1 to 10 million samples per second via the Bluetooth, have enough RAM on chip to be able to store 1 to 10 million bytes of samples, as well as implement some protocols to decode the signals for PWM, SPI, UART, and things like that, hopefully leveraging SIGROC to do some of that decoding. This application will be used by engineering students and faculty throughout UNL and other colleges and universities. I am the principal investigator and will be your primary contact, but we'll also be working with Charles Daniel and the School of Computing Computer Support team. The ultimate goal of this project is to build and test new hardware input interface into the Husker Scope app, as well as add in more capabilities into that app. I have been teaching in the School of Computing for 5 years, and in that time I've been a senior design tribe lead and sponsor for many senior design projects over the years. I also teach courses like computer organization, where students learn how to design and build the NIOS processor on a DE10 Lite FPGA. Additionally, I teach embedded systems for students to learn how to build drivers for an Arduino, interfacing with things like buttons, switches, LEDs, servos, and eventually they learn how to build a robot to drive through a maze. We also learn how to interface with an LCD display to build things like an Etch-a-Sketch and a retro Pong game. Lastly, I teach an Advanced Embedded Systems course. I've taught Advanced Embedded Systems here at UNL for 4 years now, and I taught a similar course out at the Air Force Academy for a couple years. This course teaches engineering students how to develop hardware and software interfaces of an oscope and a function generator using the Nexus Video FPGA. These students will also continue to use and test the Husker Scope app throughout the spring semester. In this course, students learn how to design the oscope display to output via the HDMI port. Next, they learn how to take the left and right audio channel inputs to be able to display those audio waveforms on the scope display. Finally, they learn how to take a soft-core processor and plug it into their hardware implementation and be able to do some additional processing on those left and right audio signals. In the last lab, students learn how to build a function generator that outputs two different waveforms through those audio channels. The problem we had was there were a lot of single function free apps available for Android, but limited free apps available for iOS, and there were no multi-function cross-platform apps available at the time. Also, microphone inputs limit the voltage range and the frequency on our application, so thus our solution is to expand the all-in-one cross-platform app to be able to accept multiple inputs and analyze analog and digital signals outside the standard audio range of 20 Hz to 20 kHz. This interface shows the current function generator and O-scope app shown on the left, being able to interface with the advanced embedded system students design on the right, where they're building their O-scopes and being able to display the outputs from the app. And they interface through the 3.5 millimeter audio jack. This diagram shows the typical pinout of a 3.5 millimeter audio jack with the left and right channels, and some of them showing the microphone input as well. Since phones these days are removing that native jack, we need to interface through a headphone jack adapter, through the USB-C or Lightning jacks, or through the Bluetooth interface. Currently, in order to get a mobile or web app to allow an external microphone input, the team had to build a small hardware interface, a breakout board, to take that left and right channel from our function generator, be able to switch between them, and then input that into the microphone input on the app. Later, we prototyped and built a breakout board for students to use in the Advanced Embedded Systems course, and that's where we're currently at. This year, we would like to redevelop the hardware interface for dual-channel O-scope and spectrum analyzer functionality, multi-channel logic analyzer functionality, increase the sampling rate for the 2 ADCs and the 8 digital inputs to 1 to 10 million samples per second, increase the number of samples collected to the 2 buffers, as well as a high-speed Bluetooth interface for all the apps. If you're interested in creating an all-in-one cross-platform test equipment app to aid engineering students, or interested in a software and hardware-driven project, please join us. I hope you join us at the Husker Scope team and continue the excellent work the previous 2 senior design teams have been able to accomplish. Thanks.